Discover the power of methanol injection for your forced induction race engine. Ideal for turbocharged or supercharged setups, it cools inlet air, prevents detonation, and enables safe boosts and advanced timing. With Frostbyte as your go-to controller, experience power gains of up to 20% without the need for high-octane racing fuel. This video is a quick demonstration of the Frostbyte 3 configuration software. Before you use the features of the software, please ensure your device is connected via the USB cable and the correct COM port is selected. You may find the COM port selection box at the top left hand of the screen. Upon establishing a connection, users can conveniently access various settings by clicking on the available buttons. Let's explore the Parameters button. This tab provides access to the configuration of the device's core operation. In this view, you'll encounter a set of parameters, and it's completely normal to feel a bit overwhelmed initially. However, these parameters become straightforward once you grasp the purpose of each control. Let's break down and understand the function of each one. Fuel injection mode. Here we determine how we control the flow of the fluid. We can spray based on a 3D table, injector duty follower, or mass airflow rate. If you look on the menu bar, you may have realized we have buttons for 3D tables 1 and 2. This is because there are two independent scalable outputs on the Frostbyte. Let's take a quick look on 3D table 1. Here you'll notice we have a table of cells that covers columns of manifold pressure, or boost, and rows of increasing RPM, or engine speed. This table can be used to determine how much water meth is to be sprayed at specific RPM and boost conditions. Let's go back to parameters. If we should select injector duty follower, you would have noticed that the grayed out area for this setting is now available. Essentially, the injector duty follower will increase or decrease meth injection rate according to the increase or decrease of your car's main fuel injector flow. More injector flow typically means more horsepower is produced and therefore more cooling is required. There is injector stay RPM, multiplier percent, and injector start boost. These parameters determine what RPM to start the spray, what percentage or ratio of the main injector's spray it should mimic, and finally, the minimum boost required before any spray should begin. Next up, we have the pump settings. Frostbyte has a dedicated output for the water methanol pump. These parameters determine what boost and RPM to engage the pump. Also, you may decide how long the pump will stay running even after the spray has stopped. It is important to say here that outside of these parameters, the pump will still engage once there is demand from the 3D table, injector duty follower, or MAF sensor. The MAP sensor. MAP sensor input is crucial in determining what boost the engine is currently experiencing. Frostbyte requires you to enter the scalar, or multiplier, and offset value to properly determine the boost it's reading from the MAP sensor input. Frostbyte shares one input for both MAP and MAF sensor, so when the MAF injection mode is used, the MAP sensor setting will not be used. Next up, RPM divisor. Frostbyte can determine the engine speed from ignition coil and coil on plug signals, as well as the fuel injector if it is the port injection kind. The divisor here allows you to multiply or divide the incoming signal until it matches what you are seeing in your car. Solenoid. As mentioned before, Frostbyte has two main outputs which can be used to drive low amperage fast-acting solenoids. These solenoids are pulsed via a PWM signal, and as such, we can use this section to determine the frequency for the solenoids. And, oh yeah, the option to enable failsafe. Let's see what the failsafe tab is all about. I should also add that a running pump by itself will not spray meth until 3D table 1 or 2 or injector duty follow or MAF spray mode decides to open and pulse the output solenoid. The pump simply keeps the line pressurized while the fast pulsing solenoid determines how much flow is provided to the engine. With Frostbyte, you can have confidence in its robust failsafe system that ensures protection in the face of malfunctions, whether it's a blockage or fluid loss. The failsafe mechanism is designed to take immediate action by interrupting the main engine control unit, ECU, reducing boost, lowering the rev limiter, and transitioning the car into a safer, less aggressive tune to safeguard the engine. Notably, Frostbyte incorporates two distinct failsafe systems, the low-pressure failsafe and the low-level, or low-fluid failsafe. The low-pressure failsafe operates by detecting abnormal line pressure conditions during system operation. For instance, if the system typically maintains a pressure of 100 psi at 30% flow, but it suddenly registers 120 psi, the failsafe system interprets this as excessive pressure and triggers a failsafe response. Conversely, a scenario where the expected pressure is 80 psi at 30% flow, but the system observes only 70 psi, prompts a low pressure warning and the activation of the failsafe. This could indicate issues such as a blockage or a failing pump. Frostbyte provides flexibility by accepting both pressure switches and sensors. While a pressure switch offers a less sophisticated approach, detecting low pressure at a basic level, sensors provide more intelligent monitoring capabilities. Users can configure additional parameters such as delay before fault triggering, reset options, and self-reset functionality. The self-reset feature automatically clears the fault after a predetermined duration. The low-level failsafe, on the other hand, also offers delay and reset options. This failsafe is typically associated with a level switch in the water methanol reservoir. When the switch detects a low fluid level, Frostbyte recognizes it as a fault and initiates the failsafe response. Let's now delve into the MAF-based injection mode, a feature we briefly skipped over earlier. MAF, or mass airflow, is a crucial metric that quantifies the mass of air entering the engine. In contemporary vehicles, a mass airflow sensor, MAF sensor, is commonly employed to measure airflow accurately. This sensor becomes a valuable resource for optimizing engine performance by ensuring the right proportion of gasoline for an ideal stoichiometric burn. Frostbyte takes full advantage of this capability by seamlessly integrating with the MAF sensor and dynamically adjusting methanol injection in correlation with airflow changes. The MAF scaling functionality in Frostbyte empowers users to create a comprehensive table where airflow values can be specified. This allows Frostbyte to interpret the input voltage or frequency from the MAF sensor accurately. Users can then utilize this customizable graph to precisely determine the required fluid flow at specific airflow readings. Essentially, the MAF scaling feature provides a user-friendly interface for tailoring methanol injection to match the unique characteristics of the vehicle's airflow dynamics. Airflow is measured in grams of air per second, or GS. Here, the user is seen moving the points on the graph to set how much fluid flow they desire at various airflow rates. Now, let's conclude by checking out the data log view. Data logging in Frostbyte provides users with real-time visual representations of system activity. Users can opt to view dynamic graphs illustrating system behavior or access the data in a tabular format. Additionally, there is an option to export the log to CSV, enabling convenient external use and analysis. For more information,